Happy learning. So today we will discuss about gear pumps. Gear pumps are one of the type in fluid power pumps. So pumps are used in fluid power applications to increase the pressure of the fluid. So to develop hydraulic energy, the pumps are important component in fluid power circuits. Now let us discuss about classification of pumps. Pumps are classified majorly positive displacement pump and non-positive displacement pump. Positive displacement pump is also called hydrostatic and non-positive is hydrodynamic. So positive displacement pumps are again classified into three types: gear pumps, van pump and piston pumps. Positive displacement pump, that is a hydrostatic pump. Gear pumps. Gear pumps are again classified into external gear pump, internal gear pump, lobe pump, gear rotor pump, screw pump. And van pumps. Van pumps are classified into unbalanced van pump, balanced van pump. And piston pumps are classified into axial piston and radial piston. And axial piston will classify into bent axis piston pump and swatch plate piston pump. Non-positive displacement pump, that is a hydrodynamic pump, is mainly used for irrigation purpose. Centrifugal pumps, axial flow pumps and radial flow pumps. In gear pump, the first one is the external gear pump. So in external gear pump, there are two gears, spur gears are attached with each other, and it is inside the housing that is called pump housing. Now these gears are moving opposite to each other, and one gear is driving gear, the another one gear is driven gear. So the left side one is driving and the right side one is the driven gear, and it is always matching with each other. So at any point of time, the one teeth will be meshing with the another teeth, and the bottom side is the inlet port, and the top side is the top one is the outlet port. Now the driving gear is connected with the motor. So whenever we switch on the motor, so driving gear will start to rotate. Now in between the gears and in between the gears there will be the oil film. Now see this, whenever the motor is started to rotate, so at that time both the gears will be started to rotate in opposite direction. So when the gears are moving away from each other, say in the bottom side, the gear teeth will be moving away from each other. Both the gears are moving away from each other, and so that there will be suction will be created, and the oil is in the reservoir, which is under the atmospheric pressure. So because of this pressure difference, the oil is get into the pump. Now the oil will be carried away. Now the oil will be carried away because of the movement of the gear. Now the oil will be carried away to the top of the pump. When it is moving into the top of the pump, there will be the restriction will be there, and the pressure will be developing. The pressure will be gradually mounted on the top of the pump. Once it is reaching the threshold level, once it is reaching the required level, automatically the discharge valve will open, and the high pressure oil will be getting into the fluid power circuit. So this is the working of the external gear pump. Internal gear pump. In internal gear pump, there are two gears, that is inner gear and outer gear, and look at the drawing, and there is the crescent wheel fixed. It is fitted on the inside the pump, and the outer gear and the inner gear, the number of teeth of the inner gear will be lesser than the outer gear. Now the center part of the inner gear is different from the center part of the pump. So the inner gear is eccentrically located with respect to the pump. Now the inner gear is attached with the motor, and whenever we switch on the pump and motor is started to rotate, and along with that the inner gear also will be started to rotate, and along with the inner gear, the outer gear also will be started to move. Now see this, the left side port is the inlet and the top one is the outlet port. Now the inner gear will be moving away from the outer gear. When it is moving so, and there is a suction will be created, and so that from the inlet through the inlet port the oil will be get into the pump. Now oil will be moving along the inner and outer gear and in between the crescent seal. And when it is moving to the top of the pump, there is a restriction will be there, and pressure will be developing, and pressure will be increasing, and once the pressure is reaching the required level, the discharge valve will open, and the high pressure oil will be get into the system, the fluid power circuit. Low pump and geared pump. The top one is the low pump, and here the low pumps are, there are three number of lobes, and both the lobes are connected to the motor, and when the motor is switched on, both the lobes will get the power from the motor, and both the lobes will be started to move in the opposite direction. Now as it is seen in the drawing, always one of the lobe is attached with it will be connected with the another lobe, and in between the lobe there will be the oil film will be there, and the lobes will touch the outer casing, and in between the lobes and the outer casing also there will be the oil film, and it is similar to the external gear pump. And whenever the lobes are moving away from each other, in the bottom, in the inlet portion, both the lobes will be moving away from it. It is moving in the opposite direction. So both the lobes will be moving away from each other. So at that time, suction will be created, negative pressure will be created, and because of the pressure difference, and oil which is under the atmospheric pressure will be get into the pump. Through the inlet, the oil direction of the oil it is shown, and oil will be moving to the top of the pump, where the volume is decreasing and pressure will be increasing. Once the pressure is reaching the level, automatically it will be getting into the system. The bottom is the gear-rotor pump. So gear-rotor pump, it is like the internal gear pump, and here there are two rotor. One is female, another one is the male one. So the inner gear and the inner rotor and the outer rotor. Now the inner rotor will be moving around the periphery of the outer rotor. Now the motor is attached with the inner rotor, and here also the number of teeth will be lesser in case of the female gear rotor, that is the inner rotor, and number of teeth for the outer gear rotor will be more. Now once the motor is started to rotate, and the female gear rotor, that is the inner gear rotor, will be started to move around the periphery of the inner periphery of the outer gear. Now see this, in the inlet port, see the right side port, the inlet port. In the inlet port, when the inner rotor is moving away from the outer one, there is suction will be created, and oil will be get into the system, and oil will be moving along the in between the inner and the outer gear, and when it is reaching the discharge port, the high pressure will be generated, and once there is reaching the level, automatically it will be get into the system. This is the working of the gear rotor. The screw pump. So screw pump is one of the types in gear pump. Here there are two rotor helical gears are moving away from each other, moving opposite to each other. One is driving rotor, another the driven rotor. And timing gears are used to adjust the movement of the driven rotor in align with the driving rotor. Here the bottom port is the inlet port, and the top one is the outlet port. Now when the motor is getting started to rotate, and the driving gear and the driven gear will be moving away from each other, when the both the helical gears are moving away from each other, at the time suction will be created at the both sides, and so that see the direction of the fluid, direction of the oil, and it will get into the, because of the suction created in between the driving and driven rotor, and the oil is getting in, and the oil will be moving along the helical grooves of the gears, driving and driven gears, and thereby it is getting to the compressor, and and the outlet through the center port, in the top port, the outlet port, the compressed oil, that is the pressurized oil will be get into the outlet to the system, hydraulic system.